All right. So with this lesson, we have talked about graphing in standard form, where I made you make a table of values. And then I made you, find the vertex and all the info about it. So now we're going to talk about transforming a parabola. Transforming a parabola means moving it left or right or up or down. And I told you about the parent function. The parent function is the basic beginning of every parabola. From this equation, y equals x squared, I can make my parabola skinnier or fatter. I can make my parabola move up or down. On the y-axis, I can make my parabola move right or left on the x-axis. Okay? So here are some sample equations that you guys are going to see today. Okay? In parentheses, x minus h. The reason it's in parentheses, just like we talked about in bell work, is because you have to pay attention to what this h number is. What this number is. And it's going to be the opposite sign that we graph and move it. Here, x squared plus k is going to move up and down. So I'm actually going to draw that for you. This is going to mean that it moves up and down. This h means that it moves left or right because it's right next to the x, the x-axis. The h is right next to the x, but it's the opposite sign. Just like if we were finding x-intercepts. Okay, so those are some things to remember today. So let's go forward, and this is the first thing you've got. Given each, and I think, wow, this is great. Okay. Given each quadratic function in vertex form, identify the vertex and graph it by shifting it. Okay, so basically, let's do a real quick sketch of y equals x squared. Y equals x squared, if I had to do some negatives and positives. Somebody plug in -1 for me and tell me what you get. And then somebody plug in +1 for me and tell me what you get. When I plug in -1, what did I get out? -1 squared, right? -1 times -1. 1. Graph -1, comma 1 on your graph. When I plugged in +1, 1 squared, 1 times 1. 1 comma 1. How about if I plugged in -2? -2 squared, -2 times -2. -2 comma 4. How about if I plug in just +2? 2 squared, 2 times 2. 4. Huh. Everything, all my y's are coming out positive. This is called the parent function. This parabola is like the beginning of it all. Every other parabola is based off this parent function parabola. The parent. From there, I can move it side to side. I can move it up and down. Okay, so now, we spent time talking about how the x-intercepts, when it's in parentheses, it's the opposite sign, right? So, tell me, just by looking at this, what's the x-intercept of this equation? The second one here. What's the x-intercept going to be? Based on the bell work you just did.
0.
Any other guesses? I'll take them all. I want to hear them all. 1. +1. Remember how it's the opposite sign? +1. So my x-intercept is going to be the +1. So please make a dot on +1 because that's where the parabola is going to have its vertex. Okay. The fact that my parabola, what's the only difference? What's the only difference between my parent function and this number 2? There's a -1, and that's the only thing that changes, right? Okay. So let's do a quick table of values. You plug in 1. Can you plug in -1? Can you plug in -2? Can you plug in 0? Can you plug in 2? Okay, go ahead and do those. All right, let's graph these. -2, 9. It's like up by the equal sign. -1, 4. 0, 1. 1, 0. 2, 1. Okay, here's what it looks like so far. Okay. So did you graph those order pairs? Finish the right side. Just follow it. Keep going up. Okay, now look at the graphs. Let's compare the graphs. Does this one look skinnier or fatter? Is the graph skinny parabola or fat parabola? They kind of look medium, the same, okay? What changed from my parent function to this parabola? How did I transform it? I moved 1 to the right. The only reason I knew to move 1 to the right is because of this. Even though it says -1, you move 1 to the right. Okay. The fact that I put a -1 in parentheses means that I moved the opposite way that number of times. I moved over a +1. Okay? So now we're going to play on this thing called Desmos. It's a website. It's a pretty awesome website. And on this website, we can look at graphs. So here we go. All right. I am going to graph the two numbers that you just had. In the upper left, watch what I'm doing. Y equals x squared. Is that the kind of graph you have written for number 1? Do your ordered pairs match up? 1, 1.
Yeah.
Okay. I'm also going to graph, because you can add like another one. Okay. The one we just did. Y equals parentheses, right? X minus 1. Close parentheses, squared. How did red change into blue? What happened? Number 1. Pick a number for me to put in parentheses. Let's do a third one. Actually, let's just do number 3 on your paper. X plus 2 squared. Y equals X plus 2 squared. Green. Red, blue, green. So this website can graph anything. Straight lines, parabolas, absolute value equations, third power equations, cubic functions. So it's important for me and for you to notice the only thing that happened here was that just like my x-intercepts, if it has a -1, it means I moved 1 positive. The whole parabola just shifted 1. Here, this shift. Green. What happened to my green? From red to green. What shift did I make? 2, but to the left. So it's the opposite sign of what's in parentheses. Okay? All right. So now, let's go on to the next slide. This one, we just did it. It was my original parent function. Can you please draw the parent function? It's the one where it's just like 0, 0, 1, 1, and what else do we have in my order pairs? 2 comma what? 2 comma 4. Okay, this is your parent function. Now, I'm going to have you do this one that I have. Is it going to go 2 to the right or 2 to the left? To the left. I want to let you know that in like terms of mathematicals, this is called my H. 2 to the left. So make your dot, and then just pretend we're doing the exact same thing. From your vertex, go up 1 over 1, left 1, up 1. Make your parent function again. Over 2, up 4. Over, left 2, up 4. So we're going to do the same ordered pairs as the parent function, but starting at my new vertex, my purple. So from your purple, from your 2 to the left, go up 1 over 1, left 1, up 1, over 2, up 4, left 2, up 4. So what I'm doing is I am just making the exact same parabola, but I'm just shifting it. It's called a transformation. Okay? Whatever the H is, it's the opposite sign. Let's go to the next one. Okay. I don't think you want to make table of values for every single one of these, do you? No. This is your shortcut. Instead of drawing a parent function every time, I can just say, oh, look, this equation is going to go over 1 to the left. And everything else will match up. So my parent function means, starting at the vertex, I go 1 over, 1 up, 1 left, 1 up. From my vertex parent function, 2 over, 4 up. And then 2 to the left, 4 up. Which direction am I going to move? I'm going to start at 0, 0. In which direction am I going to go? To the right. Because remember, it's the opposite sign. 4 to the right. So make your dot 4 to the right. 1, 2, 3, 4. That's going to be the vertex of your new parabola. I just shifted 4 to the right. Now, my parent function always has the following things. Over 1, up 1. Left 1, up 1. Over 2, up 4. Left 2, up 4. So you're going to use that same pattern to graph it. Starting at your dot, your vertex, you're going to go up 1 to the right, 1 up. 1 to the left, 1 up. Got that so far? Now I'm going to do my 2, 4 from my beginning point. 2 to the right, up 4. 2 to the left, up 4. You cannot let your parabola get skinnier or fatter when all you're doing is changing something right here. X minus 4, 4 to the right. X plus 1, 1 to the left. How about X plus 3? What's that going to be?
3 to the left.
3 to the left. Okay? So let's move on to the next page. Okay. My parent function was y to the x. Y equals x squared, right? Now let's add to it. I'm not going to put anything in parentheses anymore. So you're not going to have parentheses for these next set of problems. All you're going to have is this plus k at the end. That k moves up and down. So k moves up and down, but the sign stays the same. So turn the page and let's look at these. All right, let's graph. All right, here I go. Y equals, let's do the first one on our list. X squared, that's easy. Next one, y equals x squared plus 2. You are not going to do the opposite sign. You're going to do the same sign. It says plus 2, you move up 2. See blue? So parentheses means you shift from left to right. This k, this number at the end, like the y-intercept kind of thing. You know how we had y equals mx plus b and there was always the number at the very end? This is very much like that. This is like a y-intercept. You're going to move up and down. So your h, put this somewhere on your paper. Your h moves you left and right, but it's the opposite sign. So I'm going to put a negative sign in front of h. Negative h, opposite sign of whatever h is. And your k is always going to move you up or down. Same sign, same sign. Let me do the third one in your paper. Y equals x squared minus 3. Y equals x squared, take away 3. Look at green. The red parent function moved up 2 when it said x squared plus 2. The red parent function moved down 3 when my green equation said minus 3. H, left to right, opposite sign, okay? K, up and down, whatever it says. Now look at your paper. This website, awesome. Desmos, D-E-S-M-O-S, is awesome. Okay, we already did those 3. It's basically, I'll just sketch really fast, guys. Plus 2, same like just normal parabola. Minus 3, down 3. Basic, not too skinny, not too fat, parent function parabola. So those are the ones that I just did on Desmos.com, right? This one we'll now do. If it says x squared plus 1, what's going to happen to it? It's going to go up how many? 1. So start at your origin and go up 1. And then just make a generic parent function, not too skinny, not too fat. When my k says negative 4, what do I move? Down 4. 1, 2, 3, 4. And just make your normal parent function, just not too skinny, not too fat. Third one, when my k says negative 1, what do I do? Down 1. And then if I want to go left 1, up 1, right 1, up 1, right 2, up 4. left 2, up 4. If I wanted to make it perfect, I'd do that. Okay? This extra number at the end, not in parentheses, tells you how to go up and down. HK. The negative sign of whatever H is the number in parentheses, and the same sign of whatever K is. It's very much like X comma Y. X goes left and right, H goes left and right. Y goes up and down, K goes up and down. Okay? So what's changing is this last part where it has little written. What's changing is that you're shifting your graph up or down depending on what K says, depending on what the number is at the end. All right? Awesome. So your homework